All right, so question 8 is a conservation of energy slash spring problem. I think it is best approached from conservation of energy. And so we start out, and the spring is at rest. So we have potential energy goes away, kinetic energy goes away, plus work minus loss. I'm just going to write out all of the terms for this one just so that we can identify what we have and don't have. All right, so Hunter starts out by stretching the spring from rest, so we don't have any potential energy when the spring is at equilibrium. It's at rest. He does some amount of work to stretch the spring, and we're going to assume this is a frictionless system. In the end, the spring is stretched by 4 meters, so we have spring potential energy, and it is at rest, so we don't have any kinetic energy. So that just means that we have to plug in numbers, so work equals potential energy final, and in this case, our potential energy is coming from a spring. This equation is on your formula sheet. It's 1 half kx squared. So 1 half times 8 times 4 meters squared. And this should give you 64 joules. Very, very, very importantly, F equals kx does not work. So we know that work equals force times distance, and force equals kx. Well, in this case, the reason this doesn't work is because x is changing as you're doing work. So technically what this ends up being is an integral over the entire distance. I know you guys don't really know calculus, but it ends up being an integral from 0 to 4 meters of kx dx. So this is our force out here up front times the distance, and you integrate that from 0 to 4. And the integral of kx is just 1 half k x squared. I know you don't know how to integrate, and then you evaluate that at x equals 0 and x equals 4. And so just keep in mind that when you're dealing with springs, the force is changing, so you can't just use the simple work equals force times distance. I don't think we ever explicitly addressed that, but you could theoretically find the correct answer by using conservation of energy, which is what we did on the practice quiz and on several of the positive physics problems.